Hello everyone, this is Team Poseidon 2. We have been working on problem statement 25040, flowchart AI-powered conversational interface for outboard ocean data discovery and visualization. We have successfully built a functional prototype and design for this problem statement, which we will be looking at in a minute. As this is just a prototype of something bigger, we have trained the model on subset of data from global Argo data repository. The subset of data we have taken is of Indian Ocean in the year of 2020, which was divided into 9 folders. Each folder roughly consisted of 2200 netcdf files. Our plan, we wrote a web scraping script using Beautiful Soup to extract all these files from the global Argo data repo and open them using XArray library. Now we carefully added these rows to the PostgreSQL database, ensuring no duplicate rows are passed. Now we will talk about how we extracted the metadata for this prototype. Firstly, from the .nc files, we extracted all the columns and their descriptions such as long name, convention, and meaning of the values present in that column. Next, we have also added the latitudes and longitudes of important regions of the Indian Ocean such as Bay of Bengal, Arabian Sea, etc. into the metadata. Finally, to improve the speed of fetching data when asked for complicated queries containing floats and geospatial knowledge, we have also added float-level metadata. This metadata is divided into chunks semantically and added to the FAISS vector database. In the future, when extending this prototype for further years of the Indian Ocean, we identified performing web scraping on this website as a viable option. Now, looking at the workflow of our project, when a user asks a question, it goes to the FAISS vector database where it gathers the chunks from the metadata which is stored in the pkl file, and those chunks are ranked as a series according to the question, and it retrieves a context, and the question and the context along together goes to the LLM model. Here we are using llama. Then that LLM model generates an SQL. Okay, then that SQL is being generated or being used on the PostgreSQL, and that result is being like getting a feedback from the Postgres to the llama. From that data, we are building visualizations and such as summary with the help of tools like Plotly mostly, and the help of MCP servers we are making it. Okay, now let's look at the operable code that this prototype is built upon. For the FIASS to do its job, we loaded a Hugging Face embeddings model. We are taking the recent model, that is L6V2, and we're gonna update it as the time goes on and the new models are coming. This embedding model creates vectors and FIASS. In the step 2, the query section, FIASS using the vector store retriever, which attaches the context and question. Here, like we can see here, yeah, it at this line it divides the metadata into chunks and it stores in FAISS metadata.pkl, and while generating queries, LLM will go to this file for the access, and this thing helps the LLM to get a better thing and better at processing and all. Now, like let's look at SQL template. This is the prompt template. We have processed our model with which generates an SQL query based on the metadata and the question, and this is how we implemented a RAG architecture. Now the generated SQL query is ran and resulting SQL output is sent to the LLM for generating a summary and visualization. In this prototype for visualization, we are using a sub-branch of Streamlit which is known as Altair. In that Altair, like whenever there is the thing like longitudes and latitudes, we're gonna generate a map, and when it is like dates and time, we'll show a time series, and when it is against like categories versus the count, we're gonna show a bar chart to the user. Okay, now let's look at the results of our prototype. Let me ask it some queries like show me salinity profiles near the equator in March 2020. Here we can see the SQL is being generated, and here we can see like between -5 to 5. You might be wondering where that values have been coming from. Like as you can see here in the metadata, we have mentioned that in the equatorial region it will be around -5 and 5. So the LLM is taking those values. See, now we can see a histogram here since the only thing at the select is pixel adjusted. So it is taking it in the x-axis, like the value of pixel on the x-axis and the count of record is a histogram, and we can change this according to the values given here. Since it doesn't have any latitude and the longitude, we are not getting any maps here. Okay, now let me run the second query. Number of unique floats in the Arabian Sea. Here we can see like it is generating the number of floats that are present in the Arabian Sea, and you can also see the values here like 18 and 25 and longitude between 50 and 78, and we are also getting those values from this line. FISS like divides it into chunks as I said before, and this is one of those chunks. I think this is getting like the most priority when it is dividing the chunks. The total number of things are 84. Like the current database is based upon the Indian Ocean as of the problem statement. Like what if we ask something about Pacific Ocean? Will this AI chatbot will give us something as a result? Let us see. Count the number of floats in the Pacific Ocean. Yeah, in the rules we have mentioned like not to give any answer if it is Pacific Ocean. So the SQL generated here is like for now I'm not capable of doing this. My knowledge is limited to the Indian Ocean. Future consideration. In the future, we would like to extend our prototype to fetch all the relevant information from the Indian Ocean using a higher end open source model to retrieve and search for more complicated queries with the help of better GPUs, and also implement an easy to use and attractive user interface which we designed for our chatbot. Okay, now let us look at the design that my team made for this project. That is one of that design. Like you can see on the left, like temperature profiles and liquid levels. Same. This is the front end of that. You can see a demonstration video of that. Yeah, it is one of the demonstrations. Thank you all the judges and the viewers who are watching this video. Thank you.